Hey again, everybody, it's Jesse Beeman here. Congratulations for completing lesson 4, in which we had a look at the different ways in which you can forecast the using the different sets of data that are available to you, from the behavior of Earth's magnetic field to the speed or the density of the solar wind, and very, very importantly, the polarity of the solar wind. So we're just going to sum up all of that in a short presentation to give you another learning mechanism. And we're going to start with that KP index that we had a look at. This score system from 0 to 9 gives you a rough prediction of the latitude at which you can expect to see the aurora. And it's a very, very good visual starting point. But it is just a starting point, I must stress that. Firstly, it is only updated every 3 hours. During that time, an aurora storm can come, develop, and fizzle out again, so you could miss it if you just use the KP. Also, it's based on different magnetometer readings measuring Earth's magnetic field around the North Pole. And that's good because it tells us how Earth's magnetic field is behaving in relation to the solar wind. It tells us if there's a geomagnetic storm occurring, which is very, very important for aurora forecasting. But it's not the only data set that we need. So it's good, it's a great starting point, but we need more data. You can get the KP forecast at a website called spaceweather.com, along with some other statistics, including the speed and the density of the solar wind. Now, these are two quite important factors to consider. If we head over to Space Weather just here, this is an old screen grab, by the way. This isn't the current Space Weather page. But on the left there, you can see the solar wind statistics. You can see the speed, and you can see the density just there. Denser, faster solar wind carries more energy, which is more capable, therefore, of compressing and pinching Earth's magnetic field. Faster flowing solar wind, again, is carrying more energy, and it's more capable of distorting Earth's magnetic field. Also, when the density and the speed rise together, that indicates Earth passage through a ripple in the heliospheric current sheet. Remember in the previous lesson when we looked at those ripples where we have these regions of dense, fast-flowing, compressed solar wind, triggering aurora displays. Those are called co-rotating interaction regions, and like I say, Earth's passage through one of these regions can trigger big, big aurora. So consider the KP, consider the speed, consider the density, and also consider the polarity of the interplanetary magnetic field. That is measured in something called BZ. If we scroll down in space weather, we get underneath the KP index, or the planetary K index on the left there, we get the interplanetary magnetic field. Here, the BZ is reading a figure of 1.9 NT north, which, as an aurora chaser, is not what we want. It wants to be pointing south, and the higher the figure, the more strong that southern polarity. We want a figure of 10 or more, really, to trigger decent aurora, to allow for as much magnetic reconnection as possible. The BT just there, again, that wants to read quite a nice high figure as well, 10 or more. That represents the total strength of the interplanetary magnetic field. So that wants to be nice and high, but focus on the BZ. The more southerly, the better. The Ovation Aurora, is also available on Space Weather, and you can find it on Google as well. This gives you a very, very good visual guide to where and how the aurora is appearing. It's based on the interplanetary magnetic field, it's based on the speed and density of the solar wind, so it takes into account lots of those useful statistics, a lot of that data that we need to accurately predict the aurora. So that's a handy visual guide as well. My favourite website for forecasting the aurora, however, is Glendale Sky Auroras. It gives you a lot of information on the energy carried by the solar wind, including the speed and density. It gives you information on the three-dimensional nature of the interplanetary magnetic field and how that's affecting aurora. Also, you can sign up for live updates, which is extremely handy because if you've forgotten everything I've just said, you can get the app, you can sign up for live updates, and any time the aurora is potentially visible at your location, you will get a notification on your smartphone. It's very, very useful. as is social media. If you've got any questions about the aurora, you can go on Facebook, you can go on different pages. For example, Aurora Research Scotland just here is filled with enthusiasts who will help answer your questions if you've got any aurora-based questions, and again, provide live updates. Glendale Sky Aurora also has a Facebook page with a lot of this useful information as well. So those are my main forecasting tools. There's a few other useful things to consider as well, and first of all, we need to consider the seasons. Earth is tilted on its axis about 23.5 degrees out of the ecliptic. That's the plane of the solar system, perpendicular to the rotational axis of the Sun. Earth is tilted out of that. In the northern hemisphere, that means in midsummer on the June solstice, we're tilting towards the Sun. We have longer days, we have shorter nights. Across the Arctic Circle, on the June solstice, the Sun will not set. And so, even down here at Kielder, it never really gets dark enough in June to see the aurora unless there's an extremely strong display shining through that summer twilight. In contrast to that, the December solstice in the northern hemisphere, we're tilting away from the Sun. Across the Arctic Circle in December, on the solstice, the Sun will not rise. So you might think that that is the best time to chase the aurora, because you've got an elongated period of darkness, therefore the chances of seeing the aurora are at their highest. It's not entirely true. The equinoxes, mid-spring, mid-autumn, are your hotspots for aurora, and this is due to something called the Russell-McFerran effect. At this time, Earth's tilt, and therefore the tilt of Earth's magnetosphere, is more favourably inclined to reconnect with the interplanetary magnetic field. X points open more easily around these times due to the tilt of Earth. So if you're going to book a holiday to Iceland, Finland, Norway, Canada, wherever, don't go in the June solstice, it won't be dark enough. Don't go in the December solstice, despite the extra darkness. Go during the equinoxes, when we are more likely to have magnetic reconnection. Even a relatively gentle stream of solar wind can trigger big aurora displays around these periods. And that lasts for about 2 weeks either side of each equinox, so you've got a nice big window there. Very long-term forecasting, consider the solar cycle, which we talked about earlier on. During solar minimum, you're not necessarily going to see as much aurora. You still can, particularly during the equinoxes, don't get me wrong, but solar maximum, it is far more likely. So do as much chasing as you can, a few years either side of maximum, and if you want to chase the aurora during solar minimum as well, the equinoxes are by far your best bet. Consider light pollution. The artificial light that we generate as a species on a global scale brightens the night sky and makes it very difficult or even impossible to see anything natural in the sky, and that includes the aurora. Get yourself to lightpollutionmap.org or any other light pollution map website. Go on Google, you can find plenty, and you can see the light pollution levels nearby. On this website, lightpollutionmap.org, the brightest skies, the most polluted skies are shown in white, the darkest skies are shown in grey. So in the Kielder Forest Park there, we are blue to grey, so we've got very, very good world-class skies. In particular, the northern horizon wants to be nice and light pollution free. And speaking of light pollution, consider the moon as well. The moon acts like natural light pollution. You can still see the aurora during full moon, but it's much more washed out and there's less detail and less colour detail because of that natural light pollution. This, for example, I took near full moon, about a day before full moon up in the Cairngorms. And yes, you can still see a bit of detail in the sky, but there's very little compared to a photograph taken on a clear, dark, moonless night. And also consider Earth weather. The aurora might be dancing all over the sky, for example, but if it's cloudy, you're not going to see anything. So take into account Earth weather, the moon, light pollution, the solar cycle, the polarity of the solar wind, the strength of the solar wind, the speed and the density of the solar wind, and the KP forecast to give you the best sets of data, the best forecasting tools. And after hours and hours, or if you're very lucky, just a couple of hours of aurora chasing, putting the effort in and putting the time in, you will see a fantastic aurora display. It's only a matter of time. That's it for now. I'll see you at the end of lesson 5.1.